is that it might just sort of fold up as soon as they launch.
Layla is busy fitting the remote control system and a camera with radio link, which they'll use to gauge parachute deployment. That is, until she notices something's not quite right with the tail. Jim has put one half of the rudder on upside down.
It's a design feature.
Oh, Jim.
Well, it was a bit of a cock-up because one angle got taken off.
But isn't it a problem?
Not anymore, it isn't.
Well, to be honest, you made the mark on where to take the edge off. But, you know, I'm not apportioning blame.
Sorry, did I put the mark on upside down?
I think you might have done.
This is black powder, rafting masking, but the important thing is that this one has about half as much as this one.
So we've got to get them the right way around.
Right.
Rocketman Jeff is in charge of the electronics for the deployment system and has decided on a timing device to deploy each separation stage. If only he'd spent more time in the stores, he'd have found an altimeter, which is triggered by height and not time.
It's wired up.
Timers.
The timers
is something that worries me because
that thing will be across there in seconds.
absolutely, you know, if the glider's half a second out in its timing, then it's perhaps 20 feet away from where it should be. If the rocket's half a second out in its time, it's going to be moving at roughly 100 meters per second when these things happen. You know, so if they're a second late, then that's a fifth of the distance across the gorge out, and that's the difference between where the cross is and where the big cliffy, rocky, hard thing is.
Wall at the other side is.
Yes.
Yeah. Evening, Rocketeers. How are we all?
Good.
You've had not long to master rocket science, have you?
We won't know until we launch it, really.
So where is it?
You're seeing it right in front of you. We've got the cone, which is in the front.
Yeah.
This holds the egg inside. There's a polyester resin cast holding the egg in a hard shell.
Yeah.
That's in a styrofoam cast, and that's in this cone, which might take some impact on its own by crumbling.
I mean, it all sounds fabulous. Quite complicated, but fabulous. But are you going to get it done? That's the thing. You've got to get it finished.
This will take about an hour to assemble.
You've never done it before.
Well, we have to test it.
Just
It'll
a bunch
take
of
an hour
tubes.
to put together.
How do you feel about it?
I feel pretty confident. Just trust physics and point it at the target.
Alright, these are set.
The teams have now been working for nearly 30 hours on almost no sleep. And despite Jeff's prediction, 3 hours pass and they're still struggling to assemble the rocket.
Alright, quick disconnect is on.
This is the first charge, which is just armed. This one now is just about to go. It's getting harder for me to get.
Yeah. One thing I've noticed at this late point in things is that the sense of order and efficiency that pervaded the camp earlier on today has gone. Right now it looks like the night before a car boot sale. Over here, the Rocketeers, as far as I can see, they've got a bag of bits and then Glyn is building a didgeridoo. They're pretty confident, they say, that they can have it assembled, all of that, into a rocket, something they've never done before, by tomorrow morning and be ready to go. On the other side, the glider team, if indeed that thing is a glider, well, they've got no control over it yet. When they have got control, they haven't test flown it. So what's going to happen? But again, they're confident they'll be ready by the morning. We'll see.
Now we're going to wire up the primary charges, so I need this back like this.
As the hours tick by, the rocket team eventually get Dustin's design put together, and Jeff is desperate to test the electronics and explosive deployment system. He just wants to check the timer will work and that he's using enough gunpowder to separate the stages.
There should be plenty of room. I'm going to cover up all the other air holes so that this charge can't send any pressure wave in the other direction.
Glyn is just worried.
I'm just worried. It's a really sensible idea to test things before we can. Really sensible, Jeff.
Sure.
But we're testing whether we can blow our rocket apart in mid-air with explosives.
We need to know that the triggering sequence is going to happen correctly.
Right.
And it's going to successfully separate things.
Yep.
So, no matter what the risk, we have to test it in advance or we have no way of knowing that it's going to work.
The trouble is, if it goes wrong, it could completely destroy our rocket.
I agree with you that it's a huge risk. However, we have two uncertainties to balance out. We have an uncertainty of this doing damage to the rocket,
Right.
and to me we have a much larger uncertainty of this thing never working when it's in the air.
I disagree. We've got a big uncertainty of it working here. It might not. We hope it will. If it fails, it could fail completely catastrophically, which means that not only do we not win, we don't even take part in this test. The whole thing's over, because we're not going to be able to fire anything.
If in 24 hours we could learn and design a rocket, learn the entirety of rocket science that it takes to build some simple two-stage rocket, that we can spend the time it takes to make a test that's safe and give us the full information about how to do it for real.
Is there anything you think we can do that would make you more comfortable with the ground test?
That's a good point. That's a good point.
To make Glyn more comfortable, they agree to pad the rocket with bubble wrap, which is, frankly, pointless. It's now primed and the explosives are ready to blow.
I'm going to try and test a rocket on the ground, on some bits of paper. And if it doesn't work, it could just blow our whole rocket up. The whole thing could be completely destroyed.
So about 3 seconds after the clip, the first should go.
Right.
3 seconds after that, the second should go.
Right.
Ready?
1, 2, 3.
Nothing. Ah well.
So something didn't trigger. I'm going to turn everything off so we can actually open it up safely and figure out what went wrong.
Okay.
Once we open it up, we should be able to see what went wrong.
4 hours later, they've traced the fault, a flat battery. Now the rocket's been reassembled, ready for another test.
And 3 seconds, right?
3 seconds.
3 seconds to the first one,
Yeah.
which is this rear booster. 3 seconds to the front.
Do it. Do it.
Have a good show. You guys ready?
Well, as ready as we'll ever be.
3, 2, 1.
Yes!
Oh, piece of cake. Woo! That wasn't even loud enough to wake anybody
I've
up.
got to say, well done. That
Very
was.
Good job. Oh my god.
That was.
Good work. Good work.
That
worth
was
the
seriously
test.
excellent. Yeah.
That's probably the first time since we've been here I've just actually been able to stop and just look at the place for more than about 3.5 seconds.
This is the most beautiful workshop on Earth.
Yep. Yeah.
If we can get over there, it's going to be a pretty beautiful sight though.
Well, this is it. Very bright and very early on launch day. Now, the glider team, they all went to bed early and got a good night's sleep. The rocket team, they stayed up late and they were up before first light this morning. Atmosphere's very different. If anything, the most explosive camp is the glider teams right now. Tempers are getting frayed. But whatever happens, they've all got to be ready for the big moment in just a few hours' time. There's a lot to do. Jim is worried about his team's glider, and looking at it, you'd have to say he's got a point. And it hasn't even got the enormous egg box on it yet. For the glider to be able to fly correctly, it has to be balanced. The lift of a wing acts as if from a point a third of the way back from the front edge, and this spot has to match the centre of gravity. If it doesn't, the aircraft will either nosedive or stall. Basically, it will be completely uncontrollable. At the moment, the plane is rear heavy, and Jim wants to shorten the tail. But that would mean moving the entire remote control system, and Layla's having none of it.
Can we make this longer?
No, not really. For the amount of mass that you've got to move, the easiest way is to just move the tail assembly forward.
We do not have time to put the tail back together. Therefore, that's not an option.
No, what I'm saying is, we don't. If we trim it right, just right. We may not have any margin of error,